This is Algebra 1, lesson 10.5, part 2, where we factor in x squared plus bx plus c, picking up on example number 2. Factor in when c's value is negative. So for the first one, it says x squared minus 12x minus 64. Notice that c value right there is negative. And the other one says x squared plus 10x minus 25. That c value is negative. What that tells us is that you have to subtract the numbers, and it also tells you that the signs are going to be different. So we have 64. Other than that, we're going to treat it exactly the same. We're going to factor out that C value, 64. So 1 times 64, 2 times 32. 3 doesn't go into it because 3 times 21 gives you 63. That's because it's just one number off from 64. Um, 4 doesn't go in. Yes, it does. 4 goes into it. 4 goes into 6 once, and you have 24 left over. 4 goes into 24 16 times. 5 doesn't go into it because it doesn't end in 5 or 0. 6 doesn't go into it because 6 times 11 is 66. 7 doesn't go into it because 7 times 10 is 70, so you miss it by 1. 7 times 9 is 63, so 7 can't go into it. 8 goes into it. 8 times 8 is 64. So that once you have the same number times itself, like that last pair, you know you finish with your factors because we've covered all of them. In 8 and 8, there's no numbers in between them. So what we want to do here is we want to open up another two binomials like that and get x times x. Which pair is going to give you B's value? Again, B's value, when you combine them, just think of them as addition and subtraction at the same time. B's value is 12. As you look at 1 and 64, you get 63 or you get 65. That's not good. When you look at 2 and 32, you get 34 or 30. That's not the number 12. When you look at 8 and 8, I'm skipping it for on purpose, you get 16 or 0. That's not good. The only pair that when you combine them that gives you the number 12 is 4 and 16. 4 and 16. I told you earlier that when you look at the sign, so we have to use those numbers, 4 and 16. I told you earlier that when you look at this sign right here in front of C, it tells you that you're either going to add them or subtract them. Okay. Minus means you subtract them. It also tells you if the signs are the same sign or different signs. Negative means they're different because positive or plus told us that they were the same signs. So now we know we're going to have different signs because it says minus or negative. What you do next is you look at the sign that is in front of B. It tells you whichever number is larger is that sign right there. 16 is the larger number, so 16 is going to be minus. Since they're different signs, 4 is the smaller one, it's plus. That's how you factor when you have a negative in front of C. We'll do the same thing with 75, and then I'll move it to where we'll fill it in with all the rest of the to-do stuff. Factor out the number 75. You don't have as many factors with this one, I don't believe. 1 times 75. 2 doesn't go into it because it's not even. 3 does. We know 3/4 makes up 75 cents. So 3 times 25. 4 doesn't go into it because 2 didn't. 5 goes into it. 5 times the number 15 is 75. 6 doesn't go into it because 6 doesn't go into 15, so it doesn't work. 7 does not go into it because 7 times 11 is 77. 8 does not go into it. 9 doesn't. 10 doesn't. Those are all of the factors that you're dealing with because you get back to the number 15. Which one of those pairs gets you to B's value? B's value, again, is the number 10. So what I told you is that the more you do these, the faster you can do them because you realize that 1 times whatever the number is going to give you a big number. We're looking for the number 10. it's going to give you a number that's a lot closer to it. 1 and 75 right now either gives you 74 or 76. That doesn't work. So this doesn't work. 3 and 25 either gives you 28 or 22. Also, that one doesn't work. The only pair that when you combine them gives you the number 10 is 5 and 15. So we need to put in 5 and 15. Again, look to this sign right here. It tells you you're either adding them or you're subtracting them. Minus means you're subtracting the numbers. That sign also tells you that they're going to be different signs because it tells you same or different. Since they're different, negative means different, you look to the sign in front of B. It tells you the larger number is that sign. The larger number in this case is 15, so that number is plus. The other one is minus. That's how you factor when you have negative values. This just says they have different signs. This is what I already said, and it tells you a whole lot about P and Q that you don't really have to fool with. But when you factor it out, you get 16 and 4. Notice they just have it in a different order than I do, but the 16 is negative and the 4 is positive. P and Q are irrelevant which one you call P and which one you call Q. And the same thing with this one. They also have different signs. We talked about that already. And with 5 and 15, they probably got those backwards from what I have as well. But the 15 is positive and the 5 is negative. Again, which one you call P and which one you call Q doesn't really matter when you're trying to factor it out. On the back or on the side, whichever is easier. Factor this one, x squared minus 8x minus 9. First thing you do, open up a set of two sets of parentheses underneath to make two binomials. Make it say x times x and factor out c. So this is a simple one because 9 doesn't have a lot of factor pairs. 1 times 9, 2 doesn't, 3 times 3. Those are the only pairs you get, 1 and 9 and 3 and 3. Which pair gets you to B's value 8? 1 and 9 either gives you 10 or 8. 3 and 3 either gives you 6 or 0. So this is no good. Got to use 1 and 9. This sign right here tells us that we're going to subtract them, and it tells us that they're either the same signs or different. Minus means they're going to be different. One's going to be positive, the other negative. This sign tells you the larger number is that sign. 9 is larger than 1, so 9 is negative, 1 is positive. X plus 1 times x minus 9. Factor this one. X squared plus 3x minus 18. Do it the same way. Two sets of parentheses and factor out c. Okay, let's take a look at it. The factors of 18 are 1 times 18, 2 times 9, 3 times 6, and there's no numbers between 3 and 6 that go into 18. So those are the three pairs. Which pair gets you the B's value 3? 1 and 18 or 17 or 19, 2 and 9 or 7 or 11, 3 and 6 or 3 or 9. We want the number 3, so 3 and 6. This sign right here tells us that we're going to subtract them. It also tells us that they're different signs. This sign in front of B tells us the larger number is plus. 6 is larger than 3, so plus 6. Opposite signs, minus 3. Again, if you have these numbers reversed, if you have 6 first and 3 second, that's totally fine. Just make sure the positive is with the 6 and the negative is with the 3, and you're fine. Example number 3 is using the discriminant. Notice off to the side it says a quadratic trinomial, x squared plus bx plus c, can be factored into linear factors with integer coefficients only if the discriminant is a perfect square. So let's make sense out of that. It says tell whether the trinomial can be factored into linear factors with integer coefficients. Now the discriminant is b squared minus 4 times ac. So this is b, don't forget, this is c, and a's value is the 1 that's the coefficient in front of x squared. So b squared in this case is negative 8 squared. Minus 4 times a's value is 1, and c's value is 12. So negative 8 squared is going to be 64. Negative 4 times 1 is negative 4. And negative 4 times 12 is negative 48. So when we simplify all of that together, 64 minus 48, we get the number 16. So again, off to the side, it says it can be factored only if it is a perfect square. Is 16 a perfect square? Yes. The number 4 times 4 gives you 16. So using the discriminant says that it can be factored since it is a perfect square. The other one says x squared plus 9x minus 1. Again, a, b, and c. A's value is that same 1 that's in front of x squared. B's value is 9, and c's value is negative 1. So b squared minus 4 times a times c. B squared is going to be 9 squared minus 4 times 1 is a's value times c's value is negative 1. 9 squared is the number 81. Negative 4 times 1 is negative 4. Negative 4 times negative 1 is positive 4. So we have 81 plus 4, which is going to give us 85. Again, it can be factored only if 85 is a perfect square. There's no number that when we multiply it by itself, or let me take that back, there's no integer number that when we multiply it by itself gives us 85. That's not a perfect square. Therefore, this one, unlike the first one, cannot be factored into integer coefficients. So again, the discriminant is simply this: b squared minus 4 times a times c. You will see that again in Algebra 2 when you're using the quadratic formula. You'll notice it again in 2 years. So b squared minus 4ac on the back, everybody. Tell me if this one can be factored into integer coefficients. B squared minus 4 times a times c. If it's a perfect square, it can be factored. If it is not, it can't. So let's look and see what we got. B squared. First thing you want to do is label everything. This is A, this is B, and this is C, just in case where you don't mess up. B squared is 6 squared minus 4 times A's value is 1 times C's value is negative 7. 6 squared is 36. Negative 4 times 1 is negative 4. Negative 4 times negative 7 is going to be positive 28. So when we put these two numbers together, 8 and 6 is going to be 14. 3 and 2 is 5. Plus 1 is 64. Is this a perfect square? Yes. So since it's a perfect square, yes, it can be factored as the answer. What about the other one? I'm guessing it's not going to be able to be factored, but show me why. X squared plus 6x minus 5. So again, first thing you want to do, even if you don't write it, is you want to label everything mentally. A is here, B is here, C is here. Make sure you don't mess up. B squared then is 6 squared, same like the last one. Minus 4 times A, that's 1 again. Times C in this case is negative 5. 6 squared is the same, 36. Negative 4 times 1 is negative 4. Negative 4 times negative 5, we know a negative times a negative is a positive 20. That, when you put those two numbers together, gives you 56. Is 56 a perfect square? No. 8 times 8 is 64. 7 times 7 is 49. So it's between 7 and 8, which means it's not a perfect square, which means it cannot be factored into integer coefficients. The next thing is simple. It says solving a quadratic equation. We're given an equation instead of just an expression. It says x squared minus 6x is equal to 72. The first thing you want to do is write it in standard form. Standard form is what we've been dealing with. X squared plus bx plus c. If it's an equation, it's going to say equals 0. So right here we have equals 72. In order to make c, we want to bring 72 over. If it's positive 72 on the right, when it moves over, you do it by subtracting it. Therefore, it becomes negative 72 on the left. Now we have a quadratic x squared minus 6x minus 72. So we treat it like the other ones we've been doing. X times x. We factor c's value. C's value 72 can be 1 and 72, 2 and 36, 3 and 24. 5 doesn't go into it. 6 and 12. 7 doesn't go into it. 8 and 9 are your other pairs. I just didn't write them all. Which one of those pairs, when you combine them, gives you the number 6? Okay, so the pairs we're going to use in this case are 12 and 6. Again, the sign in front of 72, or C right here, minus, tells us that we need to subtract them and their opposite signs. So 12 and 6, when we subtract those, we get to the number 6. This sign in front of B tells us that the bigger number is negative. 12 is bigger, so we make it say negative 12. 6 is smaller, it's positive 6. Now, that's factoring it. We got that far already. Now what we're saying is it's an equation. Look at what it says up here. It says x minus 12 times x plus 6 is equal to 0. We all know how to get something equal to 0 by multiplying. In order to get something equal to 0, you have to multiply it by what? 0. Therefore, one of these parentheses has got to be equal to 0. One of them or both of them. So what you do is you create two problems based on this. You create it with this one here, x minus 12 is equal to 0, and x plus 6 is equal to 0. So we have x minus 12 is equal to 0, or I like to say and for that one, but or x plus 6 equals 0. Then it's two very simple equations that you get a value for x. You know how to undo x minus 12. You add 12 to both sides. And you know how to undo x plus 6. You subtract 6 on both sides. So therefore, x is equal to, there it goes, minus 12, and gives you x is 12, and x plus 6 equals 0. X is negative 6. Therefore, we have two solutions, 12 and negative 6. And if you plug both of those numbers back in, you'll get a true statement. X squared, 12 squared is 144, minus 6 times 12 is 72. 6 times 12, 72, gives you 72. The same thing with negative 6. 36 minus a negative 6 means plus, or times 6 means plus 36. And 36 plus 36 does give you 72. One more time on the back. X squared minus 5x is equal to 24. Solve this one. For this one, the first thing you want to do, make it say standard form. Bring 24 over. It's positive 24. You need to subtract it on both sides. That'll leave you with x squared minus 5x. Neither one of those moved. Minus 24 is equal to 0. Next thing we want to do, factor it out into two binomials, x times x, and factor out 24. 1 times 24, 2 times 12, 3 times 8, 4 times 6. Which pair gets you to b's value? 5. The only pair is 3 and 8. This sign tells us we're subtracting them, and they're different. This sign says the larger number is minus. X minus 8 and x plus 3. Therefore, we make both of these equal to 0. The first one, this one, x plus 3 equals 0. The second one, this one, x minus 8 is 0. Undo this by subtracting 3 on both sides. X is negative 3. Undo this by adding 8 on both sides. X is 8. X is negative 3 and x is 8.